You've probably heard of resistors, but there's another unsung hero in nearly every electronic device you use, the capacitor. From your smartphone to your washing machine, capacitors silently keep things running smoothly. But what exactly do they do, and why are they so essential to modern electronics? The capacitor, as we know it, has been around since the 18th century, beginning with an invention called the Leyden jar. Back then, scientists were fascinated with storing electricity. Today, capacitors come in all shapes and sizes, from tiny chips on circuit boards to massive industrial units. At its core, a capacitor is a device that stores and releases electrical energy. Think of it as a tiny rechargeable bucket for electrons. While a battery stores energy chemically, a capacitor stores it electrostatically, by holding electric charge on its plates. A capacitor has just three simple parts. Two conductive plates, where charge builds up. A dielectric, an insulating material in between, preventing direct current flow but allowing the electric field to form. And encapsulation, a protective outer shell to keep everything safe. The behavior of a capacitor is captured in a simple equation. Q equals C times V. Q is the charge stored. C is the capacitance, a measure of how much it can store. And V is the voltage applied. The larger the capacitance, the more energy it can hold. And unlike resistors, which oppose current, capacitors actually allow current to pass while storing energy along the way. So, what makes capacitors so useful? Their ability to charge and discharge quickly. This leads to some fascinating applications. They're great at smoothing power supply by filtering out voltage ripples, ensuring your electronics get stable power. In timing circuits, capacitors team up with resistors to help keep time in clocks, oscillators, and signal processors. For energy storage, they're the secret behind the powerful flash in your camera. And when it comes to coupling and decoupling, capacitors allow AC signals to pass while blocking DC, keeping sensitive chips free from noise. There's a capacitor for every job. Ceramic capacitors are small, cheap, and used everywhere. Electrolytic capacitors are larger and store more energy. Film capacitors are stable and precise. And then there are supercapacitors, capable of storing enormous amounts of energy for quick bursts. What makes the capacitor remarkable is its versatility. From stabilizing voltages in delicate circuits to storing bursts of energy in renewable power systems, capacitors play a quiet but vital role in shaping our electronic world. They're proof that sometimes the simplest devices can have the biggest impact. Imagine your smartphone without capacitors. It would be a mess of unstable voltages, flickering screens, and unreliable performance. That smooth, responsive touchscreen. Thank a capacitor. The crisp, clear sound from your headphones? Capacitors at work again. Even the vibration motor that buzzes when you get a text relies on these little energy-storing marvels. But capacitors aren't just about making our gadgets work better. They're also pushing the boundaries of what's possible in technology. Take electric vehicles, for example. While batteries provide the long-term energy storage, supercapacitors are being used to capture and release energy quickly during braking and acceleration. This not only improves efficiency but also extends the life of the main battery. In the world of renewable energy, capacitors are helping to smooth out the inherently variable nature of solar and wind power. They can store excess energy during peak production and release it when needed, helping to stabilize the grid and make renewable sources more reliable. Even in the cutting-edge field of quantum computing, researchers are exploring ways to use specially designed capacitors as quantum bits or qubits. These could potentially lead to computers millions of times more powerful than what we have today. The humble capacitor is a testament to the power of elegant, simple design in engineering. Its basic principle, storing electric charge between two plates, hasn't changed much since the days of the Leyden jar. Yet, this simple concept continues to find new applications and push technology forward. So the next time you're using your favorite electronic device, take a moment to appreciate the invisible army of capacitors working tirelessly inside. They might be small, but their impact on our modern world is anything but. The capacitor, a tiny but powerful energy keeper that ensures our devices, big and small, run smoothly. If you like this dive into electronics, hit that like button and subscribe. Stay curious, keep experimenting, and always explore science's wonders.